Class 11th Chemistry, Unit 6 Thermodynamics, and in this video we are going to discuss about standard enthalpy of reactions, enthalpy changes during phase transformations, and standard enthalpy of formation. First come to enthalpy change of a reaction or reaction enthalpy. This reaction enthalpy or enthalpy of reaction is represented by this H for enthalpy, this delta for change, and this R for reaction. Okay, how can we define it? The enthalpy change accompanying a reaction is called the reaction enthalpy or enthalpy of a reaction. Simply we can say whatever the heat changes taking place during a chemical reaction, that is known as enthalpy of a reaction. Standard enthalpy of reactions. The standard enthalpy of reaction is the enthalpy change for a reaction when all the participating substances are in their standard states. Now, what is the meaning of this standard state? The standard state of a substance at a specified temperature is its pure form at 1 bar. For example, the standard state of liquid ethanol at 298 Kelvin is pure liquid ethanol at 1 bar. Standard state of solid iron at 500 Kelvin is pure iron at 1 bar. Clear? Now in this case, temperature may be changed, but pressure 1 bar. And another condition is that substance should be pure. But usually data are taken at 298 Kelvin. Standard conditions are denoted by adding the superscript this. Okay, to the symbol delta H. For example, this is the standard enthalpy. Okay, and if we want to write standard enthalpy of reaction, then we will write this. Clear? Now, enthalpy change during phase transformation. What is the meaning of this phase transformation? Means when solid will convert into liquid, liquid convert into the vapor, or we can say solid will directly convert into vapors. These changes are known as phase transformation. First come to the standard enthalpy of fusion. Now what is fusion? Fusion is the melting, conversion of solid into liquid. The enthalpy change that accompanies melting of 1 mole of a solid substance in standard state is called standard enthalpy of fusion or molar enthalpy of fusion, and this is represented by this. Okay, melting of solid is endothermic, so all enthalpies of fusion are positive. One example is like H2O solid when convert into H2O liquid, that is ice melt. Okay, then whatever the change taking place, that is represented as standard enthalpy of fusion, or for this is 6.00 kilojoule per mole. Next one is standard enthalpy of vaporization. That is, vaporization is conversion of liquid into vapors, liquid into gas below its boiling point. Okay. Amount of heat required to vaporize 1 mole of a liquid at constant temperature and under standard pressure, that is 1 bar, is called its standard enthalpy of vaporization or molar enthalpy of vaporization, and this is represented like this. This is H2O liquid when convert into H2O gas. This is enthalpy of vaporization is 40.79 kilojoule per mole. This is again endothermic process, that's why this enthalpy of vaporization is positive. Standard enthalpy of sublimation. Sublimation means direct conversion of solid into its vapor. This is represented like this. Okay, and this standard enthalpy of sublimation is the change in enthalpy when 1 mole of a solid substance sublimes at a constant temperature and under standard pressure 1 bar. For example, solid carbon dioxide, that is also known as dry ice, sublimes at 195 Kelvin with standard enthalpy of sublimation 25.2 kilojoule per mole. Naphthalene sublimes slowly, and for this standard enthalpy of sublimation is 73.0 kilojoule per mole. The magnitude of enthalpy change depends on the strength of the intermolecular interactions. in the substance undergoing the phase transformation. If these magnitude of intermolecular forces are higher, then this magnitude of enthalpy change will also be higher. Okay. See one problem 6.7. A swimmer coming out from a pool is covered with a film of water weighing about 18 gram. Okay, how much heat must be supplied to evaporate this water at 298 Kelvin? Calculate the internal energy of vaporization at 298 Kelvin, and this is enthalpy of vaporization of water is given at 298 Kelvin, and this is 44.01 kilojoule per mole. Okay, now this process can be represented by this reaction H2O liquid converting into H2O gas, and in this case 18 gram of water is evaporating, and 18 gram of water is equal to 1 mole of water. So first of all, we can find out heat supplied to evaporate 18 gram water at 298 Kelvin is equal to N. N is the number of moles of water multiplied by standard enthalpy of, we can say, sorry, standard enthalpy of vaporization. Okay, N is 1 multiplied by 44.01 kilojoule per mole. We will get this is 44.01 kilojoule. Okay, then apply this. We have to find out the internal energy of evaporation. We use this relationship delta H is equal to delta U plus delta NGRT, where what is this delta NGRT? This is the number of gaseous moles in product side minus number of gaseous moles in reactant side, and in this case this will be 1 minus 0 is equal to 1. Okay, then delta U is equal to delta H minus delta NG RT. Delta H we have calculated, this is 44.01 kilojoule. Delta NG is 1, R 8.314 joule per Kelvin per mole. But when this delta H is in kilojoule, that's why we will also convert this into kilojoule, and that is 8.314 into 10 to the power minus 3 kilojoule per Kelvin per mole, and temperature is 298 Kelvin. Put the value. Delta U is equal to 44.01 kilojoule per mole minus 1 into 8.314 into 10 to the power minus 3 kilojoule per Kelvin per mole into 298 Kelvin, and if you solve it, okay, we will get the final answer is delta U is equal to 41.53 kilojoule per mole. Okay. Now standard enthalpy of formation. The standard enthalpy change for the formation of 1 mole of a compound from its elements. Clear? Formation of 1 mole of compound from its elements in their most stable states of aggregation, that is also known as reference states, is called standard molar enthalpy of formation, or simply standard enthalpy of formation, and this is represented by this symbol. Okay, delta FH, this is standard. Now, what is this reference state or stable state of aggregation? A reference state of an element is its most stable state of aggregation at 25 degrees Celsius and 1 bar pressure. Okay, for example, the reference state of dihydrogen is H2 gas, and those of dioxygen, carbon and sulfur are O2 gas. This is for dioxygen. For carbon, this is C graphite. Again, remember, carbon exists in the different crystalline form, but C graphite is taken as a reference. Carbon graphite is taken as a reference state. In the same way, sulfur rhombic. Again, sulfur is also existing in the different allotropic forms, but sulfur rhombic is taking as a reference state. Okay. Now we can see some more example. Like this is standard enthalpy for water. This is water is exists in the liquid form at the room temperature, and its constituent elements are hydrogen gas and O2 gas. But in its formula only one atom of oxygen is there. That's why we'll take half O2. Okay, and this is the standard enthalpy of formation of water. Dear student, you must be able to write such type of equations for the standard enthalpy of formation for any given substance. For example, this is methane. Okay, CH4. Then how can we write the equation? This is its constituent elements are carbon and hydrogen. and carbon and hydrogen present in the reference state as carbon, graphite, solid plus hydrogen as a gas. Okay, and this is its value. In the same way, this is standard enthalpy of formation of ethanol, ethyl alcohol, C2H5OH. This exists in the liquid form. Now, what are its constituent elements? Carbon, hydrogen, and oxygen. And that's why two atoms of carbon, 2C. And its reference state is graphite in solid state. For hydrogen, this is H2, and it's actually in C2H5OH, 6 atoms of hydrogen are there. That's why we will take this is 3H2. Okay, and there is a one oxygen atom in its formula. That's why we'll take half O2 gas. Okay, and this is the standard enthalpy of formation for this C2H5OH. Standard molar enthalpy of formation, or we will use standard enthalpy of formation. This is just a special case of standard enthalpy of reaction. Is it clear? Where 1 mole of a compound is formed from its constituent elements. Okay, there is again one question. What is the difference between standard enthalpy of reaction and standard enthalpy of formation? Simply we can say standard enthalpy of formation is the special case of standard enthalpy of reaction, and in this reaction 1 mole of compound is formed from its constituent elements. Now take one more example. CaO solid plus CO2 gas converting into CaCO3 solid, and this is the standard enthalpy of reaction. Now question is there, is this standard enthalpy of reaction of calcium carbonate for this reaction, can we consider this as a standard enthalpy of formation? No. Okay, why? It is not an enthalpy of formation of calcium carbonate. Since calcium carbonate has been formed from other compounds and not from its constituent elements. Is it clear? That's why this reaction does not represent the standard enthalpy of formation of calcium carbonate. Now, for the reaction given below, enthalpy change is not standard enthalpy of formation for HBr. H2 plus Br2 converting into 2HBr gas, and this is the standard enthalpy of reaction, but this is not standard enthalpy of formation. Why? If you observe this reaction, you will see that in this reaction 2 moles of HBr are formed. Okay, and again standard enthalpy of formation is considered for the formation of 1 mole of compound from its constituent elements in the standard state. Here 2 moles instead of 1 mole of the product is formed from the elements. That's why we can say the standard enthalpy of this reaction is the twice of the standard enthalpy of formation of HBr. And if you want to write expression for the enthalpy of formation of HBr, then this will be written like this: half H2 gas plus half Br2 liquid converting into HBr gas. Now this is a 1 mole. And that's why this standard enthalpy formation is half of this one. Okay, if you make it half, we will get this one. Okay. Now, by convention, standard enthalpy formation of an element in reference state, that is its most stable state of aggregation, is taken as 0. Again, remember, for the element in its reference state, standard enthalpy formation is taken as 0. Now, this standard enthalpy formation, how can we use? Actually, this, if we know the standard enthalpy formation of reactants and products in a given chemical reaction, we can find out the standard enthalpy of reaction. Take one example. How much heat is required to decompose calcium carbonate? According to this reaction, CaCO3 solid converting into CaO solid plus CO2, and we have to find out the standard enthalpy of reaction for this reaction. Okay, and this can be calculated using this formula. Standard enthalpy of reaction is equal to sum of the standard enthalpy of formation of products, and this AI represent the stoichiometric coefficient of product, minus sum of the standard enthalpy of formation of reactants, and this is again multiplied by Bi, where this Bi represent the stoichiometric coefficient of reactants. Okay, that's why for this reaction we can write standard enthalpy of reaction is equal to Now in the product side, CaO and CO2, 1 mole is there. That's why standard enthalpy of formation of CaO plus standard enthalpy of formation of CO2 minus reactant side calcium carbonate is there. That's why standard enthalpy of formation of calcium carbonate. Put the value. This is 1. Why 1? Because CaO is 1 mole. Multiplied by this. This is the standard enthalpy of formation of calcium oxide plus this is 1 into standard enthalpy of formation of carbon dioxide minus 1 into standard enthalpy of formation of calcium carbonate. These values will be provided. Okay, standard enthalpy of formation of different species will be provided. But if there is the element, again remember, if element, then standard enthalpy of formation of any element in the reference state, take it as 0. Okay, if we solve it, we will get this 178.3 kilojoule per mole. Now, if we see this value, we can say decomposition of calcium carbonate is an endothermic process. Okay, because this is positive value. Clear, student? Thank you. Subscribe my channel to get the new videos from this chapter.